Hey guys, this part of the show is called Get Real, and what we're going to be doing is going through some real life applications regarding what we've just learned. So, let's start by calculating the answer to a problem together. This is our problem. Temba walks 2 kilometers away from home, and he does this in 30 minutes. He then turns around and walks back home on the same path, and he does this in another 30 minutes. Calculate Temba's average speed and average velocity. Now, step 1 is always to identify what information is given to us and what is being asked from us. So we know that the distance and time going out is 2 kilometers in 30 minutes, and the distance and time coming back is another 2 kilometers in another 30 minutes. Okay, now step 2 is to check that all the units are in SI units. And as you know, the SI unit for distance is meters. So, to convert kilometers to meters, we know that 1 kilometer is equal to 1,000 meters. Therefore, the first 2 kilometers that he walked is equal to 2,000 meters. You just multiplied both sides of the equation by 2. Now, we need to convert 30 minutes into seconds because seconds is the SI unit for time, as you already know. So, in 1 minute, we have 60 seconds. Therefore, in 30 minutes, if you multiply 30 by 60, you get 1,800 seconds. Now, step 3 would be to determine Temba's displacement and his distance. His displacement, or delta x, is 0 meters because he started at home and he walked out, but he returned home to the same position. And his total distance is 4,000 meters because he walked 2,000 meters out plus 2,000 meters back. Next, we need to determine his total time. Delta t, or the change in time, is equal to 1,800 seconds in 30 minutes that he walked out, plus another 1,800 seconds back. So that gives us 3,600 seconds. And now we get to the interesting part, which is to determine his average speed. We know that speed is equal to distance, d, over delta t, which is the change in time. Substitute our values in, and we get 4,000 meters over 3,600 seconds. And this gives us a speed of 1.11 meters per second. Now we get to step 6, and this is determining his average velocity. Now we know that v equals to delta x, which is the change in displacement, over delta t, which is the change in time. And when we substitute our values into this, we get 0 meters over 3,600 seconds. And this gives us an average velocity of 0 meters per second. There you have it, guys. You've solved the problem.